graph the log equation y equals log base 1/2 of x by hand. To do this, we'll use a table of values. However, when graphing a log equation or log function by hand, it's normally helpful to use the equivalent exponential equation to complete the table of values. Recall log base a of x equals y can be written as an equivalent exponential equation as a to the power of y equals x. To form the exponential equation, we can start with the base and work around the equal sign. Notice a to the power of y equals x, which means in our case, the equivalent exponential equation for y equals log base 1/2 of x is 1/2 to the power of y equals x. We'll use this equation to complete the table of values. Normally when completing a table of values, we select x values and determine the corresponding y values. By looking at the equation, because we have 1/2 to the power of y equals x, we will select y values and determine the corresponding x values. And because we have a fraction raised to the power of y, notice as y increases, the x values get smaller and smaller. And therefore, let's use y values of, let's say, 1, 0, -1, -2, and -3. We can always come back and select more y values if needed. So first we have y equals 1, which gives us the equation 1/2 to the power of 1 equals x, and therefore x equals 1/2. Next we have y equals 0, which gives us the equation 1/2 to the power of 0 equals x. Recall any non-zero value to the power of 0 is equal to 1. Next we have y equals -1, which gives us the equation 1/2 to the power of -1 equals x. There's a couple ways of simplifying 1/2 to the power of -1. One way is to apply the exponent to the numerator and denominator, which gives us 1 to the power of -1 divided by 2 to the power of -1 equals x. And then rewrite it using positive exponents. We move 1 to the -1 down to the denominator and 2 to the power of -1 up to the numerator, which changes the sign of the exponents, which gives us 2 to the first over 1 to the first equals x, and therefore x equals 2. That would be one way to determine the x value. Another way to simplify this would be to recognize if we take the reciprocal of 1/2, it would change the sign of the exponent to +1, giving us 2 over 1 to the power of +1 equals x. Again, x equals 2. Next we have y equals -2, which gives us 1/2 to the power of -2 equals x. Let's go and just take the reciprocal of 1/2, which changes the exponent of -2 to +2, which gives us 2 over 1 to the power of +2 equals x. X equals 4. When y equals -3, we have the equation 1/2 to the power of -3 equals x. X is equal to 2 divided by 1 to the power of +3, or 2 cubed. X is equal to 8. Let's go ahead and plot these 5 points and see if that's enough to make a nice graph of y equals log base 1/2 of x. First point is 1/2, 1. Next we have 1, 0, which is the horizontal or x-intercept. Next 2, -1. 4, -2. And finally we have 8, -3. We can make a pretty accurate graph using these 5 points, but let's determine one more point. Let's see what's happening to the graph as the graph approaches the y-axis. Let's select y equals 2. When y equals 2, we have 1/2 to the power of 2, or 1/2 squared equals x, giving us x equals 1/4. 1/4, 2 is approximately here. Notice as we select larger and larger values of y, the x values get smaller and smaller and approach 0, which indicates the graph has a vertical asymptote of x equals 0, which is the y-axis. Let's go ahead and graph this using a dashed horizontal line. Again, the graph is going to approach the y-axis of this dashed line, which again is called a vertical asymptote, but never touches it. And now let's make a nice graph of our function passing through these 6 points and approaching the vertical asymptote. The graph looks something like this. Again, it may appear as if the graph touches the y-axis, but it actually doesn't. And now let's talk about some additional properties of log functions or log equations. When we have a function or equation in the form of y equals or f of x equals log base a of x, the base a is greater than 0, the input x is greater than 0, and a can't equal 1. If a is greater than 1, the function is increasing. If a is between 0 and 1, the function is decreasing. Notice the value of a for our function or equation is 1/2, which is why the function is decreasing or going downhill from left to right. The domain is the open interval from 0 to infinity. The range is the open interval from negative infinity to positive infinity. The vertical asymptote, which we discovered, is x equals 0, which is the y-axis. And the horizontal intercept is 1, 0, which we can verify from our graph, this point here. I hope you found this helpful.